It's not really, as a concept, a difficult concept to understand, which is why it goes right down from kind of your low ability SEN groups all the way up to your top sets. It's not a difficult concept. What it is, though, it's a chance to actually collect data and interpret data and actually get reproducible results of which they can be critical about in real time. That's the skill we're investigating here. We're looking at how does the speed of a truck change as it moves downhill. Now I'm hoping you'll instantly say, oh, that's easy. That's easy, I know exactly what happens to the speed of it. But what I want you to be able to do is to be able to use the data loggers to actually find out how it does change, whether it changes in a regular way, whether it changes in a slightly irregular way. You're going to look, you're going to investigate that, and you're going to get some real measurements for yourself. That's the whole point of this. So here we have our ramp, and we have our trucks. Okay? Now, we're going to have to do this in a kind of regular way, because what we want to know is, as you go down the ramp, how does the speed change? Can we say what the speed is at that point, that point, that point? Therefore, can we predict what the speed will be? But what we're going to do is you place a small piece of card inside your truck, okay? And you need a small piece of blue tack to secure the card on so it doesn't fall out. There we go. All right. And then we're going to hold the truck at the different distance and drop it. Okay? Now, you need to be able to measure the distance it falls from. So what would be the best way to do that? Go on then, Andrew.
Ruler.
Pardon?
Ruler.
Use a ruler, thank you. So, I'm going to place the ruler on the side of the ramp. I have a starting point that I can use. There are lines on there. You can put your own lines on if you like. Then, I can place the truck just at the top, and then I can release it, and I can work out how fast it's going at different points. Now, this is where the technology comes into it. Okay? Now, I'm going to have to do this experiment time and time again, because I want to know, after it's travelled 20 centimetres, what its speed is. After it's travelled 40, 60, 80, 100. So how am I going to do that?
Take photos, and the time distance between them is...
Good idea. That's a really good idea. I could take photographs, okay? And that is how we used to do things in the past. Yes. What about you? What do you think? Come
on. Well, would you put laser beams on the track, and then as it breaks the laser beam, see when, and then when it breaks the other one, see when that happens, and then get speed?
That's a clever idea. And in fact, it's very close to what we're going to do. Well done, Daniel. Okay. So let me show you what we're going to use. These things are called light gates. What they have inside here is a small little light sensor on that side, and this one gives out light. Now, when we connect this to the computer, as the truck falls down the ramp, it will cut the beam of light, pretty much like Daniel was saying, okay? And then, when it's gone past again, it will then detect the light. If we tell the computer how long that piece of card is, it will automatically work out for us how fast the vehicle's going. Okay? So what you're going to do is, once you've set your ramp up, you're going to choose at what distances you're going to measure the speed, and then you let go, and the card has to cut the light beam without hitting it. Okay? That will be for 20. Then you'll do the same thing, making sure I drop it from the same point again, but this time I'm going to hold the light gate at 40. Okay? What are we looking for when we collect the data? What type of data are we looking for?
Is it a best estimate?
It's a best estimate. Fantastic. By taking repeating measurements, we're getting the best estimate. And what are we looking to try and take out from that, Laura?
Correlation. A
correlation. Good. And what if I have a set of data and one of the figures looks a bit odd? What would I call that type of data? A few more hands there. Yes, on.
An outlier.
An outlier, fantastic. Okay, so we're looking for outliers, we're looking for best estimates, we're looking for a correlation. We're trying to see what happens to the speed as we move down the ramp. And we're trying to see if there's a regular pattern or whether it's doing something totally different. All right, guys, off you go. I think the students really enjoyed the opportunity to actually physically get a nice little practical going of where they were looking at something that they had a pretty good understanding of anyway, in terms of it speeds up as it goes down the ramp, but could we get any reproducible results? It also allowed me to reinforce the ideas of collecting data, looking for outliers, working out an average, and it's also now starting to link into some of the other things that we're having to talk about, which is to do with speed, velocity, and it brings out questions and it gets the intrigue in mind going, and that's what's really nice about this practical. All I want to know is if you've not got something, you need to ask me where do I get it from, okay? You've got one light gate. If you've got two, you only need one, okay? 1 meter rule, 1 truck, 1 piece of card, okay? And the card is securely attached to the truck. And you should have a piece of foam, which you have to hold, otherwise it will knock it off because these trucks are heavy. Next thing. You need to attach your light gate onto this sensor here in number 1. We'll be fine. Okay?
You sure we start right? Yeah. You sure we start press square? Right.
Yeah.
Who's holding
Yeah.
Ready? Yep. We've got an error. We've got an error.
That's what the phone's for, people. You're going to hold it. Right, in your books, please, I want a table with the distances that you're going to take the measurements. Make sure you've got at least 3 to 4 gaps so you can put down the speed at that point.
Speed.
So, okay. Right. Lift up. I got it. 1.0. I'll start from the same place, but put it at 1.047.
This is the first time they've used the light gates, and setting them up takes a little bit of time. Using it with quite a large piece of equipment, I mean, you're talking about a lot of skills here. You're talking about coordination, you're talking about management, you're talking about group skills. All these things have got to come all at the same time in order for this practical to work. And I think, you know, they did really, really well, and they were able to actually work as a group, assign roles to certain people. You do this bit, you do that bit, and they did that really well. And using the equipment for the first time, within 15, 20 minutes, once they knew what they were doing, that's it. And that's the beauty of the youth today. They can do that. They're so ready just to pick up and adopt new technologies. They don't have a problem with that. It's only just teachers that do.
So that's 20, that's 60, that's 1 metre.
It's not a difficult concept. What it is, though, it's a chance to actually collect data and interpret data and actually get reproducible results of which they can be critical about in real time.
Right at the top for 20 centimetres, you just have 1.172 metres per second as an average speed. Right, and at 80 centimetres, we have 1.861. So we must deduce that it will accelerate.
Because it helps you work out the averages a lot better than just looking at it and guessing. You'd have to do it by eye and use stopwatches, things like that, so it'd be a lot harder.
Without the light gates, it's very difficult to actually do these types of activities. I'm sure lots of people would have the old ticker tapes, and I remember using those when I was a student, which was some time ago, and they're kind of very difficult to set up, laborious, and I think, to be honest, you lose a lot of the impetus because they can't get immediate results, whereas with this, within one lesson, they were able to get a set of results, plot the data and look for the pattern, whereas there's a lot of analysis that needs to be done with the ticker tapes, and it takes a little bit more imagination, and there's a lot more teaching that has to be done in order just to get them to get the results so they can use those results. If I now select all these, and then I choose this one, yeah? Remember it?
Yeah.
Okay, and I'm going to choose a graph. Now the one I'm going to use is, I'm going to go for scatter, and I'm going to ask it to plot it as a line, like that. And there you go. There's your data. Okay? So if you go down to here, and then you can put in what is the title. Well, this is truck down a ramp. Okay, and the value of the x-axis. So what have you got on the bottom? 20, 40, 60, 80?
Oh, so that's the distance.
Distance, good. Okay, and press finish. There's your graph. Okay, so, is there a pattern there?
Yeah.
We've only got 4 data points. If we were to collect more, we would probably find that it would end up here, here, and here if we did ones in between, wouldn't we?
Yeah.
So what we find is as you go further down the ramp, what happens to the speed?
It gets faster.
It gets faster.
There's a chance to speed up.
Yeah. And therefore, do you think that if you were to plot a line along a piece of paper like this, do you think you'd be able to predict what the speed might be if you went further down the ramp?
Yeah.
And it would make sense, wouldn't it? That the further down the ramp you go, the faster you're going. Yeah? Okay? Now, before, you wouldn't have known how the speed changes, but like looking at this data there, we can see how it does change, and that's the whole point of this.
Where's our line graph?
Third one.
Yeah. Line.
We need
Next.
Or maybe a scatter.
Series in.
Very good, I like it. That's a nice graph. Yeah, the fact that they could do it so easily, so quickly, and get results, and with one short lesson get a nice graph and able to come up with a prediction, just goes to show how far they can go in a short amount of time. And I think that's the power of the data logging.
So you could say that there be a good correlation.
There's a good correlation between the two, yeah. The further down the ramp you go, the faster you're going to go. The pattern becomes pretty obvious very, very quickly, and you ask anybody, they would pretty much come up with the pattern without even trying the experiment. But they actually could see that you get more or less a straight line, and within the limits of this experiment you would expect a straight line, and therefore they could use that to go on and predict. And it's that skill that is very difficult to teach, and it's very difficult to get that idea across, and that's the hard to teach part of the topic. Some people have got their own graphs, which is fantastic. I tell you what, some of the data has been very, very precise. Very, very accurate indeed. Can anybody tell me, have they actually managed to spot a correlation, a pattern between the distance down the ramp and the speed that you're going at? At the back there, please.
the further down the ramp it goes, like the faster it is.
Brilliant. Okay. And can anybody say anything else about that pattern itself? Because we've got the further down the ramp, the faster it's going. But what can we do with the data we've got? Can we do anything with it?
You can predict what's going to happen next.
That is absolutely right, well done. And that is the key thing here. With the data loggers and with using the computers, you can plot the graph and you can see there is a regular pattern emerging, a correlation. Okay, we discussed correlation over the last kind of months or so, and you can see there's a distinct correlation. The further down you go, the faster you're going. Okay, thank you very much, guys. You may go now.